equals. So far I've asked you, a quadratic function has x to the what power? Second. It's a square. Diego, right? X is being squared. Ian, help me focus. My next question was, what shape letter of the alphabet does a quadratic function curve look like? My third question, what's the technical term? Parabola. My next question, concave up or concave down? What do you guys think this example, what type of concavity this example would have? Why concave up? Because A is positive. Think, a smile. You're a positive person, concave up, right? Now, do I know exactly where it is? Not yet. Not until we learn today's lesson. But I know it's concave up. So what if I was to ask you something like y equals negative 7x squared? Down the ground because it's a negative. Right? Negative people, pessimistic people usually wear these. Now, sometimes life makes you wear those, and it's not your fault. But it's a way of remembering. When something negative is going on, I think, Jordan, you were talking about that. When something negative is going on, or when you are a negative person, sometimes you can wear a frown, right? If you're a positive person, usually you try to wear a smile. Concave up, concave down. Okay, let's go and check that homework, huh? Didn't homework start with some of these questions?
Yeah.
Wasn't it 1 through 5?
Where he went? Here he is.
Well, sorry.
Okay, ready? Number 2. Number 2's answer. Come on.
Whoa.
This one?
Number 4. Why is it?
Alright, number 2. You were answering 2 questions. When is the graph going to be, they say concave up in the question?
Down and up.
Okay, so concave up when A is positive. Did you have to say greater than 0? And the answer is no. You could have said when A is positive. You didn't have to put the greater than 0, but greater than 0 is right.
Oh, it was 2.
You could have just said when A is positive, and concave down when A is negative. You could have done the snazzy inequalities or just say concave up when A is positive. So it is negative. If it's a 0, 0 times x squared is 0. The x squared isn't there. It's not a quadratic. It's actually going to be probably a line.
No.
Now, number 4. You guys are supposed to find the special characteristics in the graph, and what special characteristics did they say? The vertex, you had to find that first, like we did in class. The axis of symmetry, maybe you're still learning how to write that. We didn't really write it down yesterday. But the straight vertical line was x equals negative 2, and then you were supposed to answer your 4 questions. Domain, all real numbers. Range, y greater than or equal to 4. Increasing when x is less than negative 2. They said that. I don't like how they said that. Can I write it the way that we should write it? We talked about whether the graph was going up or going down. So I would say instead of this comment, guys, the number 4, was it concave up or concave down? Concave down. So I would say the graph or the y's are decreasing for x greater than negative 2. Exactly. And increasing for x is less than negative 2. Remember how I say sometimes the book does it in a way that I wouldn't do it? You guys said it was concave down? Oh. Okay. Well, I heard like 4 people say concave down. Is it the wrong question? Okay, we're on number 4. So what is that going to change? Concave up. Increasing will be the first. Decreasing on the other. Alright, guys, make sure you're So increasing x is greater than negative 2, decreasing x is less than negative 2. So clearly it was bad that you had to change it, but good that you had it right the first time. Last but not least, 32 and 34, 14 and negative 25. Kiddos, I'm going to go back to your notes real fast. 32's question was this. How are you supposed to get that answer that we just checked? Wait, should we go back real fast we can see it. Unless lots of random things open at the same time. The orientations are a little off today. Let's see. The answer for number 32 is 14. What were you supposed to do if they gave you an N and they gave you an X in algebra, Angel? If they say evaluate and they give you stuff? Plug it in.
Plug it
Plug it
in.
in. Plug it in.
3
So
squared
3
plus
should have been
5
squared plus 5.
equals 14.
That was so easy.
PEMDAS says,
Or 9 plus 1.
now you guys see why I had you go to the end of homework
Yeah, I was
for the first section, right?
My 32 to 34.
I think today you might figure out why I had you do that, because today we're going to start. Whoa! The warm-up for today is, I'm going to have you turn in your homework right after I go through the directions. The warm-up for today is, in your notes, continuing section 8.1.
I just realized any number positive,
Squared?
squared is positive. That's so cool.
Yeah. Because negative or positives go in and only positives come out.
That's so
Let's have this be a safe space if that does.
Oh, I thought it was cool.
Okay. Just watch the sarcastic tongue. Jen? Kiddos, I'm really trying to get you going. I'm going to collect the homework as soon as I go over the directions for the warm-up. So notes are open. You guys are continuing in section 8.1, so I don't want to hear that question from anyone. We are continuing 8.1. It's on the board, and I've said it like 4 times now. I want you guys to fill in a table. Now, if you like homework problems 32 through 35 last night, where it was just plugging in, this shouldn't be bad. Because all it's saying is, here's a function.
Oh, I get it.
You can think of f of x as y equals x squared, which is a quadratic, the easiest one, because it's just a 1 in front. When x is negative 2, when x is negative 1, 0, 1, and 2, what is the y value? And all you have to do is plug it in. Homework, pass to me, as you guys work on your homework. Thank you.
Very.
The homework I collect tomorrow better have tables and graphs on it.
What's the date?
No,
Is that
it's on first.
Wait, tables and graphs?
Justin, can you hear me then?
Oh, man.
No, it's not gonna be that.
He would say it don't. I wish I could get on it. If it can't get AB,
All right, guys, you write it down.
AB is the highest number.
Sorry, give me 1 second. Kiddos, Caleb, I would love to answer Jordan's question, which is off topic, but it's still, I think, important to her. But I really need you guys finishing the warm-up. So notes open. Notes open. You're filling in the table by plugging in x's to the function. Okay, focus. Jordan, you're helping by last night. Sigma. That's a Greek letter sigma.
Yeah, what does that mean? I have no idea.
Summation notation.
Yeah, totally.
I'm going to kind of use the quadratic idea from what we're doing here.
Is that?
Something that you guys will learn in Algebra 2.
Whoa.
Summation notation says, take the bottom number and plug it into k, put a plus sign. Take the next number in between 1 and 3, and then solve.
So where'd you get the? Okay. Wait.
You count between bottom to top.
Alright.
So you plug in 1 and then 2, 3.
Is that 3
Okay,
over
and the
2?
K squared, and
I
then
know.
you get the.
Alright, kiddos.
Oh, wait.
Okay, let's go ahead and stop the spinning thing just because yours makes a little bit of noise. If you can get a quiet one, that'd be great. The noise just kind of distracts people.
Yeah, when you put on this air.
I just know I heard it yesterday. I'll just let you, because I know that you don't want it. Diego, what are you explaining? Go ahead and let me know. Okay. So Ian, how do you do the table?
So basically it's x, right? So it's a negative 2. Really, the negative 2 goes to the x.
Good.
Negative 2.
So we're plugging in to evaluate, right? So then if you guys wanted to, we could show our work, which most of you will kind of see as a little bit excessive in the sense of how much work to show. We could say at x equals negative 2, we could plug in and say let's not even be that complicated. Let's just take the equation and say, what are we going to be squaring if x is negative 2? Mm-hmm. Now, somebody made a little baby mistake in this. Negative 2 squared, if you plug it in, it goes inside. Think about the x as always having little parentheses. Oh man, that's what you're teaching. Yeah.
Ooh.
It'd be negative 2 times negative 2, which is what?
4.
Positive 4. Check your answer. Did you put positive or negative?
Positive.
Hey, careful. Remember what Jay said earlier? Whenever you square positives or negatives, they should always end up being positives. Let me go ahead and get to the notes that we're going to be taking, which is over here. Then I can use my iPad. That's not the one I want. And you guys can focus a little better. Yesterday I tried it with the smartboard, but I couldn't see you, and you guys, every time I kind of like turned just a little bit, it did. And it was crazy. So let's go ahead and try to focus a little better today. So, if you plug in negative 2, and you square him, he becomes a what, Aiden?
Negative 2, 1.
So let's just keep on going. So negative 1 squared, Neve, what'd you get?
1.
Good, because negative 1 times negative 1 is a positive 1, right? Is that a little thin? Give me a thicker marker. Let's try a little thicker. Okay, so positive 4, positive 1. Rob, what's 0 squared?
0.
Good. Josh, what's 1 squared? And Alan, what's 2 squared?
4.
Got it. What are we supposed to do with those points once we have gotten the table?
Parabola.
Now, Dylan, whenever we have x's and y's, do you remember which one we tend to graph horizontally?
Nice.
Good. So if you look at the table, technically if you want, we could go ahead and write each of the points. And that's not that you have to write every time, it's more for you guys to realize every time you fill in a table, you're actually finding pairs. That's a snazzy term from before. So if I go from negative 2, positive 4, do you guys see how this should have been the point that you filled into the graph?
Yeah.
Okay. Negative 1, 1. Now, these units go by 2, so it's a little bit harder to do. So negative 1, 1 would be approximately there. Where's 0, 0? Always. In the middle, and what's that special point called?
The 8.
Vertex of a parabola in this case, but normally it's called the starts with O. And
Origin.
Origin. I couldn't think of anything to do. Origin. Then if you guys keep on going, do you see your U shape?
Yep.
Looks like a V, but what do we know it has to be? A U. So what we need to make sure to, that's not actually on 0, 0, is it? Let's make it better.
There you
And that doesn't really look like 1, 1 either. Struggle. Okay. We know it needs to be a U, so I don't want you guys to ever connect it in a point. Make it rounded. Okay? Make it rounded and then go up. Make it rounded and then go up. Yeah, don't have it come like as a V to a point. Make sure you have it come rounded. Does that make sense? Yeah. U shape, that's what I'm talking about. Exactly. It'd be a different type of function. So, I want you guys to go ahead and think through with me one more point. In the table, we only did negative 2 to 2. But what if I was to want one more point and actually go to when x is 3? If my function is f of x equals x squared, it'd be 9. So I could go ahead and graph one more just so I can make sure I know exactly how steep to make it. Does that make sense?
Yeah.
Then let's put an arrow. And did you guys notice the symmetry? What's on one side ended up doing what on the other side? Yeah, being copied. So we can go ahead and go negative 3 and then go up 9. And then we can know exactly how steep to make it. So see how it's going a little bit off without my points to guide me? This is the basic parabolic graph of x squared. How did we find it? What did we do? Plugged into a table. And where did the -2, -1, 0, 1, 2 come from? I gave it to you. Now, are things going to get maybe a little more complicated? Possibly, but not too bad.
Oh dear.
Ready? That was the most basic parabola. Is this one a lot different?
No, it just has a number in front of it.
Just has a number in front of it. A number multiplied by it. So the old y values, x squared, just got multiplied by 2. Yeah, start writing in your notes. Graphing quadratics. We're going to use tables to help for right now. Donnie, once you have lunchtime today, let's go use that. We're still in 8 1, so you can just keep on going. We're going to use tables to help. Now, if we get into another section like 8 2, 8 3, we might have some formulas to kind of help us know how to make tables. There are other clues that we could use to graph, like x and y intercepts and stuff like that. But for right now, at this level, the introduction to quadratics, we're just going to go ahead and use tables. Now, guys, what do you notice about this table?
It's done for you.
Has a G, and it's done for you already.
Yeah, go back to 3.
Oh, it already is done, right? Oh, okay, so you worked on the new table?
One step up.
Not in the hallway this
Freshman. Kindergarten hours. Same thing.
Nope.
So Islamic.
That would have a vertical shift down like this. Jay,
On the homework, it said, like, write the something, I forgot what it was called.
compared to the graph of
No, not that, it's a graph, and then it said write the.
Why don't you wait until we get closer to the end, then I'll let you go look at it. Or you can borrow yours. Alright, you talk it out. What are you guys describing back there? What are you learning? Okay. Didn't I just say that? Oh. But I think that was already talked about. So let's make sure we're only talking about what's most important. Okay? So, if you guys already pointed out, or actually Angel already pointed out, it's already done for us. Now, are the ones in homework going to already be done for us? And the answer is no. But why did I give you these ones? Because they're examples. James, don't ask me one more question right now. Jordan.
If you're doing a graph like this, can you essentially just do -2, -1, and 0, and then just do the flip side of positive?
If you're doing -1, -2, 0, yes, except be careful when we get to the future sections. We're always going to copy that way negatives and positives.
But if it's ax squared,
Then you
always gonna be.
So, if you guys notice, just like the page before, Jordan's saying, you know what, I think I might see a shortcut. She sees a shortcut. If you have the ax squared, what's on one side, isn't it going to be on the other side? Yeah, that's pretty cool. So maybe we don't have to do quite as much work. Still, hang in there, bud. Gotta wake up. So we go to graph. If you guys notice, for the first one, when x equals -2, could they have plugged in and done 2 times -2 squared? You see how they plugged it into the function?
Yeah.
What did they end up getting? Even though I didn't make you do all the work for this one. Uh-huh. Do you see how it's a positive number? Why is it a positive number? A negative times a negative is a positive. So when you square any number, PEMDAS says do the squaring first and then go ahead and plug in chunk. So I only showed one example of how they got 8. But then guys, if I were to go ahead and graph this, have you guys graphed point by point? If I was to graph the new one, here's a question that is going to be asked of you in homework. The question is, how does this new graph, which we're going to connect with a U, is it a very narrow U? And the answer is yes, it's narrow. How does this compare to the graph that we just did a second ago? All right, Johnny, let me see your graph. Let me see it. Same as mine? Okay, then fix it. So, how does it compare? Can anybody tell? Look at the points. No? Alright, I'll go ahead and help. What were the points of the last table? Go ahead and read them off to me real quick. -2 is at 4. -1 was at 1.
0, 0.
1, 1, 2, 4.
Okay. Now, can you help me out a little bit further? Where was 3 at?
3, 9.
Okay. Do you guys notice the difference between what we had a second ago for normal x squared and what we have now for 2x squared? Shrinks is kind of good, but the problem is it doesn't exactly model what's going on. I would say the following. I would say that this graph, how does it compare? It's narrower. Narrower than y equals x squared. Can we say that? Is it narrower? It lost weight, sure. It's narrower. But another way of saying narrower is that it had the y values stretched. Now wait a minute, hold on, stretch, I thought it was shrinking. Question, what's shrinking? Are the heights shrinking? No, what are the heights doing? They're getting higher, right Jordan? So if the heights are getting higher, that means that the y values are stretching. Now, what are the x values doing, Dylan? Horizontally I'm shrinking, but vertically I'm stretching. Horizontally I'm shrinking, but vertically I'm stretching. Okay? So, I kind of like, even though the book's going to be all snazzy and say something about a vertical stretch by a factor of 2, can we just say it's narrower?
Yes.
Or can we just say the y value is stretching? Question, what's different when we get to a new function? Don't worry, I've done the table for you.
No.
Don't worry, we see a fraction, but I've done the table for you.
I already took on this.
Okay.
But wait, question,
Fractions on the test.
pause, that's not the most important question right now, we're trying to learn. So come back.
Started the section.
Can anybody tell why? You guys are killing me now. Can anybody tell why it's going by 6 and 3s and not by 2s and 1s? Okay. It's okay. Go ahead, Jim.
The denominator is 3, so the divisible by 3.
Yeah, they don't want to go using 1s and 2s because if you divide that by 3, it's going to be yucky. But you can, since you're making the table yourself, you can choose the numbers to use. So therefore, you guys filling in, let's go ahead and fill in this example. If you see a fraction, you can make things better. You can make the numbers nice if you use multiples of the denominator. So start at 0, 0 still. Start at 0, 0 still. But we can use a strategy. We can be creative with math, and we can say if we can make the table, we'll use multiples of that nasty denominator that we don't like. And as you guys are writing the table, I'm just going to show off to the side the very first one and the work that should have been done to make it what it is. Because if you remember, didn't Jay say a second ago, whenever you square, the answer becomes a positive? Well, what are all these answers besides 0? How did that happen? Well, you guys write the table. And let me show you how it happens. You guys writing the table? But good thinking. I like what you're saying. The negative does get squared. Right, Diego? What happens when the negative gets squared? It becomes a positive. But Ian, what's outside the squaring that still keeps it a negative? The negative 1/3. So even though the negative 6 did become a positive 36, we had a negative waiting for him. So sadly, the answer returns to be a negative. Does that make sense? But hold on, what's 3 into 36? 1 and 12, right? We can reduce 36 over 3 to be 1 and 12. We end up with negative 12 as our final answer. Now, if you guys have not yet, graph those points. And I want you guys to think about, as you graph those points, how it compares to the original.
And it's upside down.
That's only part of it, though. Graph those points. I'm going to graph them as well. Let me see your table. The last time I asked, it needs to be done when I ask, not you doing it when I ask. Okay. Negative 6 goes negative 12. Isn't that kind of below the graph? Did you guys figure that out?
Yes.
Okay. And then negative 3. Negative 3. Doesn't this seem kind of wide? find it. Yeah, I feel like I'm making it a lot wider when I connect it with my U shape, right? Perfect. It's pretty good.
This way,
Alan,
is that concave up or down?
what do you think?
Down.
Like a friend.
Okay, because you got me confused with homework. Because you said one of them was down, so I got confused.
Because number 4 you said it was
Oh, I was actually asking people what it was.
Okay.
And so I heard the answer down. I didn't even have the problem in front of me, so I took it. So they were accidentally looking at number 3. So you're right. Number 3 was down, number 4 was up. I just didn't have the problem, so I used their answer and it was wrong. Good question, Alan. Now I'm going to go ahead and really quickly, guys, I'm going to show the 0, 0, 1, 1, negative 1, negative 1, 2, 4. You see how I'm graphing the basic y equals x squared again? I'm just going to ask you the question, what changed to get this new one, which is negative 1/3? I'm looking for 2 big changes, negative 1/3 x squared. Jay, what's one of them?
As A got smaller, the got bigger.
As the number for A. Now the sign of A, hold on, Justin, you pulled this one out a second ago. Aiden, I'm up here. Hi. Justin, you pulled out that this is not concave up, but concave
No.
and why?
because the negative sign.
Okay. So because of the negative sign, because A is negative, it made it concave down. So how does it compare? It's concave down because of the negative. The book would say something snazzy like a vertical reflection or a vertical flip. Because it's flipping the parabola down. Does that make sense? We can just say concave down. It's concave down, and what else would I say? And Jay said when A gets, not the sign, but the number. As A gets smaller, because it was 1, now it's 1/3, what happened to my parabola? It got wider. So I'm going to say concave down and wider than. So in your homework, when it tells you to compare, are these descriptor words good if I'm using them in class? Yeah. You don't have to be all snazzy and say, ooh, there was a vertical reflection about the x-axis and vertically stretched. I wouldn't say that. Horizontally stretched by a factor of 3, or we could say vertically compressed by a factor of 3. That's confusing. Right now in Algebra 1, let's just say that it's concave down, first of all, and second of all, it's wider because the A is small. Does that make sense? Okay. So when we go graphing, we're going to watch out for negatives and positives, and we're going to watch out for big A's and little A's. The bigger A gets, what happens to my U? The narrower it gets. And then the smaller A gets, the wider. Yeah, I can think of it that way. The fatter the U will get, or the wider the U will get. So you guys, ready, set? Let's see what you can do.
Oh, wow.
Find me the points, graph,
Oh, wow.
and then tell me the comparison.
It's already looks hard.
Why is the first thing?
Wait, it doesn't look hard. Just use the example.
Oh, my.
Okay, let's do it. I got it.
G of X. That's G and a
Oh,
half.
thank you. Very already got a good typo.
Isn't X-ray supposed to be there? Or
Well, remember in the beginning, weren't the tables filled out for you?
Yeah.
In homework, aren't you going to kind of have to come up with it yourself?
Well, I thought, so not X, like, not top row, but
Nope. Because to be honest, in homework, you have a blank piece of paper that you're trying to figure out. Does that make sense? Okay, so when you go to make your table, my question to you is, does negative 2, negative 1, 0, 1, 2 work, or should I maybe do like bigger multiples?
it'll work.
I could do bigger.
It can work. It will work.
It'll work. I don't have a fraction. I don't need to change it up. I don't have a fraction. Just do normal. So Angel, even though the numbers aren't there, that was because I wanted you guys to think. Can I just do negative 2 to 2? And the answer is yeah. There's no fraction. Only when there's a fraction should we maybe change it to make the numbers nice.
So,
Why am I writing y when the beginning wrote g of x? Yeah. Good. f of x, g of x, h of x are a special notation for y.
right?
Oh, like we're good. G of x. Diego? Y is the general term, G is a special name. Y is the general term, F is a special name. Does that make sense? So Y works is a simpler way of saying G and F. Okay. I'm just gonna plug in just a couple kiddos to see how we did. Did you guys get 20 for the first?
Yeah.
Positive 20, right? No negatives out there. There can't be unless there's a negative on the outside, like the negative 1/3 problem, right? I'm not going to do all of them, but then we would plug in negative 1, 5 times 1. PEMDAS says you square it first. And then we would get 5. Now, Jordan, hold on. Use your pattern. If negative 2 gets plugged in to be 20, negative 1 gets plugged in to be 5. Hold on, what 0 gets plugged in to be? Same thing. Okay. So Caleb, what happened when you graphed it? How would you compare? How would you use those words that we were using to compare this to x squared? When you graph, you're supposed to put the points, right?
Yeah, the point.
Okay. When you graphed it, how would you say it compared to the original y equals x squared that we were looking at?
It's like the y, the x. I think the x is decreasing.
Say it one more time. The x is decreasing or increasing? Good. We can say the x is decreasing or the x has narrowed.
And the y is increasing.
Good. So we could say the x's are decreasing and the y's are increasing. Another way of saying that? Vertical stretch. Another way of saying that is it's narrower, right guys?
Yeah.
Right?
Yes.
It's narrower. Is it still concave up?
Yes.
Yeah.
So we'll say narrower and concave up. So it stayed concave up and it got narrower. The snazzy math terms would be a vertical stretch.
So yes.
And Caleb, if you stretch a rubber band, doesn't it get narrower and taller?
Mm-hmm.
So that's what's the idea, a vertical
Rubber
stretch.
bands.
Yeah, kind of.
Good job, Swanson.
Oh, why does it graph?
Well, we're supposed to compare, and I did compare. Remember how I would write the other one, the old one? I would say 0, 0, 1, 1, 2, 4. I just didn't do all the graph this time, so I think you guys noticed that it's going to get narrower.
Oh, I think
Those extra noises, guys. Exactly grown-ups.
Oh
Need some more grown-up than an elementary kid.
Panic. Mature changes. Panic.
Oh, we're doing
What's different?
You have to put narrow.
It's
a fraction.
Angel, narrower is the descriptive word for comparing.
I'm panicking.
Johnny and Jay, go ahead. What's showstopper?
No, I thought you had another one.
So if we were to plug in our table, kiddos, what do you think? Should we use -2, -1, 0, 1, 2? No.
You should do.
Hey, there we go. But why is Kaylee saying we should use -6, -3?
Because it goes by 3.
Yeah, we have this nasty 1/3 on the outside that we don't want to mess up our numbers, and we don't want to do fractions and whatnot.
No, you did not.
So I'm only going to plug in just a couple of them, kiddos. When we plug in the first one, we have 1/3 PEMDAS with the negative in the parentheses. Is this going to end up being a positive or a negative?
Positive.
The square makes positive and the 1/3 isn't negative. It's going to keep it positive. And the nice thing is we already saw these numbers. -6 squared is going to be 36, right?
Yeah.
And what's 36 cut into thirds or times 1/3?
12.
12. 36 divided by 3 is 12. If you guys were to plug in -3, which some of your classmates already have, -3 squared would be positive 9, right? What's 9 over 3? Let's use Jordan's trick. As long as we don't have any pluses or minuses, we only have ax squared, then question, Daddy, do you remember what's going to go in the 0 spot? Good. And do you remember what we can do to finish to the table? Look at the other ones above. How did we finish the table up there? Did we have to plug in more? Nope. So what do you think we could do with the 3 and the 6? Yeah, we could plug him in. We could plug him in, but do you see his pattern? 20 and 5 and 0, and what happened as we kept on going? Yeah, it's predictable. Okay, so what are we going to do down here? Yeah, so we can use 3 and 12, only because this has a axis of symmetry as x equals 0.
Let's say like there's negative 12, but the other side also has to be negative 12.
As long as you only have ax squared, there's no adding or subtracting going on. A parabola will always have symmetry. What's on the left will copy on the right. Now, next section, we're going to see ones where there's adding and subtracting, and maybe our parabola gets shifted, and so we're going to have to be careful with that. Okay?
And when is that?
Next section, so you don't have to worry about it right now. Hey, kiddos, what happened? How wide is this puppy?
It's super.
Oh my god.
So how are we going to describe it? Because this is part of the What are we going to say? What's the better way of saying it? Because huge,
That's
I mean,
it.
no. I want you to compare it to y equals x squared. What's the word?
Wide round.
Wider. It's a comparative, right? Wider. Wider. And what else I want you to say in your description? Wider or narrower and concave up or concave down? Concave up.
Is the Y increased?
They are.
How?
We would technically say on the left the function is decreasing, right? Roller coaster car. And on the right the function is increasing.
Left to right, right? Okay.
Read it left to right. That's how the roller coaster is always going to go on these ones, left to right. Now guys, I'm not going to go super crazy, but can I just ask you one more example? Yeah. We're going to stay for an extra minute or two. Let's do this one. That's it. That's one.
Okay.
Wait. 840. Why are you using that one, Jack? Because he sees that 1/4 and he says, you know what, hold on. I think it might be easier to use multiples of 4. What do you guys think?
I think so.
That's cool.
Good.
So then we go to plug in. Show off if you guys know what to do.
4, 2, 0.
Wait a minute, but how would you plug in, Rob? Because you shouldn't be guessing. Negative 1/4 times, what happens in negative 8? Negative 8 squared turns into a positive 64, but question, kiddos, what's that negative 1/4 going to do?
Divide a negative.
Make it a negative. Now you might need to do 64 divided by 4 on the calculator. But negative 16 is going to be the value. Did anybody plug in negative 4? What'd you guys get?
Negative 2.
Actually, not negative 2. That's okay.
8.
Negative 8.
4. It's okay, we got it.
4?
It's actually going to be negative 1/4 times 16, which is going to be negative 4. And what do you guys think I'm going to do over here?
Same thing except positive?
Nope. It's actually going to stay in negative because Rob and everybody else. The negative is on the outside. So what's true about all of our answers? They're all negative. What's going to be true when I graph?
Concave down.
Wait.
Negative 4 is going to be at negative 4. It's going to be way out here. 4 is going to be at negative 4, way out here.
Isn't it always?
Alright, what's the homework?
It's always going to be concave down when we have what kind of A on the outside? When we have a negative A, isn't it going to be concave down the front?
Always.
Yeah.
And my question to you is, for the comparative word, are you going to say wider or narrower if it's 1/4? Cool.
Is there homework?
I'm going to go ahead and show the homework. However, I'm going to go ahead and let people leave based on how they did in class today. So go ahead and get a picture of the homework if you guys want to. It's numbers 5 through 12.
That's good.
Maybe as soon as you have homework, you may leave. Where are you going,
Can
Ben?
I leave?
Nope, not yet.
Yeah.
You have been dismissed yet. Today when you have homework, you may leave. Molly, when you have homework written down, you may leave. Lou, you may leave. Rob, you may leave. Griffin, you may leave. Jack, you may leave. Justin, you may leave. When you're ready. Angel. you for your class, Angel. Let's try to do a little more focus
My bad.
tomorrow.